All right, so just to review you on how to find holes, earbuds out, right? Lynn, thank you. Comics away. Oh, did you find it already? Okay. Find the coordinate of the hole. So I give it to you in factored form real quickly. We know that there's a hole at the factor that divides out. So that's at x equals -2. Yeah. But to find the y value, all we got to do is plug it back into there. So if you want, you could say y equals x times x minus 1 all over x plus 3, where x cannot equal -2. This would be the simplified form, right? And then to plug in, you could say y of -2 instead of f of -2. It's going to be -2 times -2 minus 1 is -3. All over 3 minus 2 is 1, and that gives you +6. So the coordinate, so we would say then f has a hole
at -2, 6.
-2, 6. Yeah, very good. All right, easy. So we'll see an example where we have a hole, and a hole then becomes another point that we can plot, but we don't plot it with a solid dot. We plot it with an open circle. Yes, sir. Oh yeah, photographs. And y'all want to take it out in the hallway? That'd be better. Yeah. Okay. Here we go. I just put it all on a tray for you. Well, it's all on one easy serving tray. That's really all I have. It's a breakaway cone and cube, and then a Tower of Hanoi puzzle. Is that enough for y'all? Yeah. Yeah. Okay. Sweet. Have a good one. All right. So we're going to skip around on some of these. Like, again, I gave you a bunch of different examples. I want to jump down to Q on page 3, example E, Q. Q of X. It's a good looking letter, okay? We got a cubic over a cubic. It's a rational function. We're going to do the same thing. We're going to organize all our information, and we're going to sketch a graph of this dude, okay? So what's up, Q? Hi. We're Mr. Corpy's first period pre-cal class. We're gonna probably vote for number 1, I'm guessing. All right. 3 actually doesn't look too bad. Yeah. 4 looks like sick, like really like I need to be in the hospital sick. Yeah. All right. So then we factor it, right? So Q of X is, first rule factoring is common factor, right? So we pull out a 2x, and that gives us x squared minus 9. And the bottom we pull out an x, and that gives us x squared minus 4. All right, now we continue factoring. It looks like we've got a difference of 2 perfect squares in both the top and bottom. So that always factors into the product of 2 what? Conjugates. Good. X minus 3, x plus 3. X minus 2, x plus 2. And there's the complete factored version. So now we'll find the domain. You always find the domain, remember, before you divide anything out. So D sub Q, ooh, Dairy Queen. It's going to be the set of all x such that x is not what values? 0. Don't forget that first. And then you can say plus or minus 2 if you want, right? 0 plus or minus 2. Now, does anything divide out? Yeah, actually it does, right? The x's divide out. So that means that at the root of that factor, which is which one? The 0, the 2, the -2? 0, we're going to have a hole, right? So let's go ahead and write the simplified version. Q of X, or you want to call it Y? You can call it Y. Let's call it Y like we did in the warm-up, because we're about to plug something into it. Now you could still call it Q of X, but when you plug in your 0, you don't call it Q of 0. So we'll call it Y equals 2 times x minus 3, x plus 3, all over x minus 2, x plus 2. And then we warn people, hey, don't use the 0. There's your simplified version. So we're going to use that for everything except finding the Y, or even for finding the Y value of the whole, okay? So now we'll say that Q has VAs at x equals 2, x equals -2. Remember, don't list those as a conjugate pair because we're not listing x values. We're listing equations, right? So we need to see two equations. Those are the two non-removable factors. And then Q has a hole at 0, comma. And then what do you get when you plug a 0 into Y? Let's come over here and plug it in. Y of 0. So you can't call it Q of 0, but you can call it Y of 0. It's going to be 2 times -3 times +3 is -9. And the bottom, you get -2 times +2, which is -4. Right? And so what does that equal? The 2/4. Well, if y'all like to multiply across, so you get 18 fourths. I would encourage you to divide, but the negatives divide out. That's nice. So you get 9 halves, right? 9 halves, which is the same as 4.5. Okay. So it has a hole at 0, 9 halves, whichever you want. As long as it's terminating decimal, they're the same. It doesn't really matter to me which one you use. Okay. All right. So now that we've classified all the discontinuities, we are going to find the other asymptotes, which are the end behavior, if there are any. And for that, we go back to the original one, right? It's cubed over cubed. They grow at the same rate. Whenever that happens, the end behavior is always going to be leading coefficient over leading coefficient. So let's go ahead and write out the analysis. The limit as x goes to -infinity of q of x is, what was it, 2/1, which is 2. And the limit as x goes to +infinity of q over x is also 2. And therefore, or so, we can say that q has a ha at y equals 2. Okay, so now at this point, since I haven't really started my graph yet, we have a lot of information. Let's go ahead and start that down here, right above the example 3. I'll give myself a y-axis and an x-axis. And then I'm just going to go ahead and pick a flavor. We'll do blue. Let's do the 2 asymptotes first, -2. And I'm just going to draw it as a dotted line. It's a little bit faster than switching. +2. Something like that. I've got the horizontal asymptote, which is at +2. So I'll put that up here. All right, and then I'll label everything. We got x equals -2, x equals 2, and y equals 2. So very similar to what we did yesterday, we've got 2 vertical asymptotes, which kind of divide the graph up to the left of the leftmost and to the right of the rightmost. Then something interesting can happen on the interior. Yeah. All right. And then there's one other thing we can still plot. We can plot the point, which is really the lack of point. It's the hole, 0, 9 halves. So that's where it's useful to know that it's really 4.5. So there's 3, 4, here's 5, here's 4. So right here, I'm going to put an open circle. And I'm going to use red for the graph. It'll stand out from the blue. Okay. All right. At this point, then, we can start looking for x and y intercepts. Let's see if we can do that. X intercepts, y intercepts. Remember how we find x intercepts? We show that we're setting the whole thing equal to 0. And that's going to equal 0 when the numerator is 0. But remember, we can't use q of x factored with everything there, because there's 3 values that originally make the numerator 0, right? 3, -3, and 0. So we have to use the one with the hole gone. So once the holes are divided out, there are still 2 values that make the numerator 0, right? 3 and -3. So those are going to be the x intercepts. So you can list it like that. You could say q of x equals 0 when x equals ±3. And then you list them as ordered pairs. That's -3, 0, +3, 0. Well, I can plot those dudes. So let me go ahead and do that in red. -3, 0. That's an x-intercept. +3, 0. Another x-intercept. Looking good. Hey, this graph, just kind of FYI, do you notice anything symmetrical about this graph so far? With respect to what? Even or odd? Y-axis or origin?
Y-axis.
It looks like it might have y-axis symmetry, right? Everything that's happening to the left is happening to the right of the y-axis and vice versa. We'll check for that here in a second. What about y-intercepts? Well, that's when we plug in a 0 for x. What do we know about plugging in a 0 for x? It's a whole, right? So equals DNE or none. You can say none. Yeah, we already know it's a whole. All right, so at this point, then we would look for other judicious points if we don't already know where it lives. Okay, so let's look at symmetry real quick. Symmetry. If you look at the first term in the top, it has an odd exponent, right? So that's going to be an odd term. In other words, plugging in a positive number and a negative number, they give you opposite outputs. Plugging in a 1, you get out a +2. Plugging in a -1, you get out -2. So that's an odd term. What about the 18x? That's also an odd term, right? So the top is going to be an odd function. In the bottom, you have an x cubed, which is an odd term, and a 4x to the first, which is an odd term. So the bottom is also an odd function. What's an odd divided by an odd? Kind of, yeah. It's like a negative divided by a negative, which would be positive, which remember, odds act like negatives and evens act like positives. So an odd divided by an odd is an even function, and an even function does have y-axis symmetry. Now that could be really, really helpful, okay, if you didn't already know. So I know then if I can figure out what the graph looks like in quadrants 1 and 4, I can essentially reflect it across into 2 and 3. All right, let's see if we can finish out the graph. It's going to have to do this on that side, which means it's going to have to do this on this side. Now, in the interior, remember, like we saw yesterday, knowing that it's symmetrical is helpful, right? It can't be increasing through it like we saw yesterday or decreasing through it, because that's not symmetrical. It either opens up on both sides or it opens down on both sides. But can it open down on both sides? No. Because remember, the evidence is not just what's there, it's what's not there. If this thing had opened down on both sides, what would we have already found? 2 more x-intercepts, actually, right? We would have found 2 more x-intercepts. Are they there? Nope. So I guess then they are not there. It must open upwards, and it approaches the vertical asymptotes on each side. Hey, it's not a parabola, because a parabola, as it goes up to infinity, goes out forever to the left and right. This one just stays between -2 and 2. So there it is. There it is. Now, I think for the first time, we can figure out the range. Let's go ahead and write the range of Q. It's a set of all y's such that, well, coming in from -infinity, let's do it in interval notation. It might be easier.
Yeah.
The set of all y such that -infinity up to what value? 2, right? Where the horizontal asymptote is, with a bracket or a parenthesis? Parenthesis, because we don't touch it or cross it. Union, and then what y value do we pick back up at? 4.5 or 9/2 with a what? Parenthesis or bracket? Parenthesis, and then we cruise up to infinity. Yeah, very good. So knowing that this one was y-axis symmetric helped a little bit, although we didn't need it. Okay. The points themselves told the story. And then I can ask you, other things like what would be the limit as we approach, 0, from the left side, or how about this? What would be the general limit as x approaches 0 of q of x? Good morning. The limit as x goes to 0. The general limit.
I don't know if this is a trick question or not. Something approaches 0. Smaller. But it stops at 2.
Up on the graph and start heading towards 0 from both sides. We're getting closer and closer to, no, not 0.
No.
What's the y value there? 4.5. Thank you. It's the y value of the whole. The y value of the whole is always the general limit value there. The general limit value is always the y value of the whole. The y value of the whole is always the general limit value. Yeah. And let's do this one. Limit as x goes to -2 from the left. Negative infinity, right? Or what? D&E. Yeah, good. All right, so that one didn't take the whole period, did it?
No.
Because we're getting better.
But it did take my whole page.
Yeah, I did take the whole page, right?
Didn't take the whole period.
So tomorrow you'll have an open note quiz, and there'll be one question, and it'll be partitioned with different sections that guide you through it, very similar to what your free response question will be on Thursday. Okay. All right, comments or questions on that one? Fun. Okay. Yeah, sorry, bless you. Hey, let's look down here at example 4. Instead of me giving you the equation and saying graph it, what if I told you to write your own equation and gave you some requirements? That sounds fun. That sounds really fun. Construct the equation in factored form of a holy graph. Ooh. With holes at 1, 5, -4, and x-intercepts at 2 and -6, a vertical asymptote at 3 and 6 with a horizontal asymptote at 2/3. What the? That's a tall order there, right? Imagine trying to take that order at the drive-through. Can you please repeat your order, sir? I got the hole at number 1. Okay, we could do this. First thing we need to do is give our equation a name. What do you want to call it?
G.
G? Capital G or lowercase g? Capital G. Yeah. Oh, cursive capital G. I like that. Y'all even know how to draw that? There we go. Pretty good. G of x. G of x. All right. I know it's going to be a quotient. So to have a hole at x equals 1, I need a corresponding factor of what? Not -1. X minus 1. Yeah. And I need it in the top and I need it in the bottom. Because that's how you generate a hole. Okay. X minus 5 then as well, right? X minus 5, X minus 5. Sweet. If -4 is going to be a hole, then the corresponding factor is X plus 4. I thought this was supposed to be challenging. Yeah, so far, so good, right? All right, x-intercepts at 2 and -6. So if 2 is an x-intercept, what's the corresponding factor? X minus 2. And does it go in the top, bottom, or both? No, it's an x-intercept. Just the top, right. Remember, if it's a factor just in the top, it's an x-intercept. So I got an x minus 2 up there and an x plus 6 just in the top. Now, if it's a vertical asymptote at 3 and 6, those are just going to be factors just in the where? Just in the bottom. So I'm going to have an x minus 3 downstairs and an x minus 6 downstairs. So that takes care of all of that. And now I want a horizontal asymptote at 2/3. Well, if you notice, there's just as many x factors on the top as there are on the bottom, right? So remember, in order to have a horizontal asymptote other than 0, I need the degrees to be what on top and bottom? The same. Are they currently the same? Yeah, I'd have a 1, 2, 3. I'd have a 5th degree x in the top, 5th degree x in the bottom. And notice all of the coefficients of x are 1. So all I have to do then to get the numbers to work out is just to put a 2 in the top and a 3 in the bottom. What? Yes, way, right? And it said to give it in factored form. So I don't expect you to multiply all that out. That was too easy. I'm sorry for insulting y'all. That was way too easy. So that would make like a good multiple choice question on a test on Thursday.
It's not very hard. It's just very long.
Yeah, but at least it fits on one page.
Yeah. You got me there.
Pretty good at doing that. All right. Let's see. Well, man, there's some crazy ones. Nah. You want to graph? No. Nah. Can't really do this one because I haven't taught you about essays.
And I don't think we can hand graph up to 500.
Ah, you doubt yourself. SA is a slant asymptote. I'm not going to mess with that. I'm not going to tangle with that. So let's jump down here to example 6. We'll say this is the last one that we do. Okay, last one. 2, 3. Chills. Yeah. Chilly. That's where the chills get their name. The name of the function is, let's see, do we have time? We have time. All right, let's go ahead and factor this dude, right? Factor it. I hope it factors. Let's see. The top, x, it's already partially factored. Very nice. X minus 5, x plus 1, looks right, I think. X plus 2. And the bottom, x minus 3, x plus 1. Yeah, that looks good. I like that. So now D sub L is the set of all x such that x ain't 3, -1. Excellent. Yes, very good. Because that's not, I didn't even check my own work. X plus 2. That gives us a -6. Yeah, very good. Thank you. So that'll change things. Good eye. Hope the Astros have a good eye at the plate tonight. 3 and -2. Awesome. Yeah. So now what divides out? Not the x plus 1s as I was trying to make, but the x plus 2s. So we can say that L, right? L has a vertical asymptote at x equals 3 and a hole at what? -2, comma. Now you don't have to write that as y if you don't want to. You could just say that this equals, you can come right next to it and write the simplified version if you want, all over x minus 3, and then say that x cannot equal -2. And then to get the y value of the whole, of course, we plug a -2 directly into where we just said not to use it, right? And so if you don't want to say y of -2, we'll just do it off to the side in our workbench. Let's do that. -2 minus 5 all over -2 plus 1 all over -2 minus 3. So that's -7 times -1 over -5. And that looks like it's going to be -7/5. That's an awesome number. Okay. Yes. 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 Mm-hmm. All right. I'm going to go ahead and start my little sketch over here off to the side. I have two things that I can plot. The vertical asymptote at 3. 1, 2, 3. There you go. And then the whole at -2, -7/5. -2, -7/5 falls, it's about what? -7/5. It's between which two integers? -1 and -2, right? So somewhere, I'll just put it right here, open circle. Okay, and if you want to mark this, you could just say it's -7/5. Okay, that'll work. All right, awesome. Hey, let's look for any end behavior asymptote. We go back up to the original. Darn it, there is no original. So look what we can do. If you want, you can actually remultiply these back together. Once you get rid of the whole, and you get x squared, inner and outer are going to give you -4x - 5 all over x - 3. You don't have to expand the original one. You can just expand what's left after you get rid of the whole. What grows faster for large value of x, top or bottom? The top now. So that's going to be different. Are we going to have a horizontal asymptote if the top grows faster? No, we're not. That's only when they grow at the same rate of the bottom grows faster. So we know that both of these then, since the top grows faster, they're both going to be some type of infinity, remember. All I need to do is figure out which type it is, right? So remember how we do that? Plug in, yeah, plug it in. So if we're going to negative infinity, plug it into the leading terms. In the top, a negative squared is positive, and the bottom, a negative, right? It's just x, so it's a negative. A positive over a negative is a negative. You just plug it into the leading terms, that's it. And as we go out to the right, we get positive squared over positive, that's positive. So opposite end behaviors, okay? Opposite end behaviors. All done? There you go. Did it work? Good, good. Which one? The big one. Oh, nice. You moved all the discs. You know what that's called? Yeah, yeah. Tower of Hanoi. All right. Thanks, guys. All right. So there is no horizontal asymptote. So what else can we do? Well, I guess we're stuck with the intercepts, right? That's where we're at. There's no other asymptote to draw. So let's look at the y-intercept. And for the y-intercept, that's L of 0. Now, again, for L of 0, since the original function wasn't factored, you can actually go back and use this right here. You can use that expanded version with the whole factor gone. You can use it for everything else. So when you plug in a 0, you get -5 over -3, which is 5/3. So that's like 1 point something as well. So right there. And then any x-intercepts? Well, let's see. L of x equals 0. And again, on the test, you want to show me that. After the whole is gone, what are the two factors that still make the numerator 0? X - 5 and x + 1, right? So the two roots are 5 and -1. X equals 5, -1. So the points are 5, 0, and -1, 0. So we can plot those. 3, 4, 5, 0, and -1, 0. Any symmetry? Doesn't look like any symmetry is happening, right? Based on our graph. So this, it just won't have any symmetry. Now, we're kind of stuck, believe it or not. That's why this is kind of at the very end. I want to show you something. I'm not going to ask you this on the test, but There is another asymptote. We're going to call it a slant asymptote. If you were to just simplify these leading terms, okay, we know that the top is bigger than the bottom, but if you just write that off to the side as y equals x squared over x, if you simplified, what would that simplify to? What is x squared divided by x? X to the first, right? Guess what this graph says? Not a horizontal line, but a slanted line. So slanted lines are of the form y equals mx plus b. So we have the first term of the slanted line, 1x. There could be a plus b, a y-intercept that we could find, but it requires a lot more math. So at this point, if we just know that there is a slanted line asymptote or an SA, we can actually draw it in there as a slanted line. We know that the graph is going to infinity on the right and negative infinity on the bottom. That's just like what the line y equals x would do, right? But we're going to draw it as a dashed line, not a dotted line. Now, where do we draw that? That's a good question. Again, without actually doing the math and finding the b value, it's going to be kind of hard. Well, let me just show you. Okay. If you lean in real carefully and listen to this right here, what does that say? That's not just x squared minus 4x minus 5 over x minus 3, but divided by. So if you lean in, you're going to hear it say, divide me. Divide me. Let's divide it. So here's how we do long division. X squared minus 4x minus 5 divided by x minus 3. Have you ever done long division of polynomials? Did y'all do that in algebra 2? Maybe, yeah, okay. So I will review you how to do it. Again, you won't have to do this on the test. This might be a good bonus question on the test, actually, okay? When the top is bigger by exactly 1 degree, your quotient is an x to the first, okay, which is a slanted line asymptote. All you do is look at the first terms first. How many times does x go into x squared? Well, instead of saying how many times does x go into x squared, that's the same question as what is x squared divided by x? X to the first, right? That's where y'all were saying once. It goes in x times. X goes into x squared x times, all right? Now, you put that above the x squared, and then you multiply from up top. You distribute, okay? X times x is x squared. You write it underneath. What's x times negative 3? Minus 3x. You write that underneath the minus 4x, okay? And now you subtract, right? That's what we always did with numbers. So we do the same thing here. We subtract, which means we change both signs. Your x squared minus x squareds cancel, which give you 0. And then you get negative 4x plus 3x, which is negative x. And then you bring down the minus 5. And now really all you have to do is one more time, okay? How many times now does x go into negative x? Not quite. Again, that's the same thing as asking yourself, what is negative x divided by x? It's negative 1. That goes here. And look what happens when you multiply. You get negative x plus 3. And then when you change the signs, they're going to cancel. So you can keep going if you want. But look what we have up here in the top. That's your quotient. I was really just after that minus 1. You can get the x very easily by looking at the leading terms. But to get the y-intercept of that line, you need to do long division, at least one iteration. So guess what? We can say then that this function, L of x, has a SA, a slant asymptote at y equals x minus 1. So what that does is now gives us something else that we can sketch. Okay, here's minus 1. I'm going to go up 1 over 1, up 1 over 1, so on and so forth. And I'm going to graph this like this as a dashed line. Okay, And what that does is it gives us now kind of like the 4 quadrants that we would expect if there were a horizontal asymptote. It's just slanted. So now your graph is to the left of the vertical asymptote, either going to live above or below, and to the right, it's either going to live above and below. Well, we have the evidence now, right? So look how much easier this is to draw now that we know that that's there. These don't really line up correctly. This should be closer to over here. This graph is going to do this. If you extend this slant asymptote, it's going to come from there, and it's going to pass through these points, and then it's going to get closer to the vertical asymptote and turn upwards. Okay. So the slant asymptote basically tells you how it's going down to negative infinity as you go out to the left. If you're a classic rock fan, you can call this right here the highway to hell. If you're an AC/DC fan, okay? It tells you how it's going down to negative infinity. It's going to get closer and closer to that line. In fact, if you were to zoom out into outer space, you wouldn't even see the local behavior. You would just start seeing the line y equals x minus 1. And now over here on this side, it's going to come from the vertical asymptote. It's going to pass through there, and it's going to go this way. Okay. And so if you extend this out, this right here on this side becomes the Stairway to Heaven, if you're a Led Zeppelin fan. All right. And notice the end behavior. We already knew that. We can find that without finding the asymptote. But how is it going to infinity as we go out to the right? It's going out along the line x minus 1. Okay. Now, because this one's not a horizontal asymptote, if you were to actually graph this, and I don't think we have enough time to do that, if you were to graph this in this window, you would see all of this. This is your local behavior. But guess what happens if you zoomed out repeatedly like Jeff Bezos did when he went into space? You would not see that detail. All you would begin to see is the line y equals x minus 1. It would look from space like the line y equals x minus 1. You would just see like the 2 roads heading out of the city. And you wouldn't really see the city detail unless you got close. Okay. So I'm not going to ask you about slant asymptotes on the test, but do know that there are other asymptotes out there. If the top had been x cubed and the bottom were x to the first, now the degree difference is 2. Guess what? Graphs as a degree 2 polynomial, a parabola. You would have a parabolic asymptote. You could have a cubic asymptote, so on and so forth. Y'all are just responsible for finding the degree 0 asymptotes, the horizontal ones, okay? All right, so that's all we're gonna do then with this 2.2b. Make sure you know how to do these problems, work some from the, there's no key to this worksheet, but I won't have you turn the worksheet in, okay? Just because there's too much work to do. But tomorrow in class, you'll do your open note, or we might make it, yeah, we'll see, an open note quiz, okay? And it'll be like your free response question. And then we'll go over it at the end of class. So you won't have the whole period to do it, okay? Probably give you 20 minutes to do it, and we'll spend 20 minutes going over it. And then we'll talk about the test. Your test will be chapters 2.1, 2.2, and 2.2b, okay? All right, any questions, comments? Awesome, no.